Welcome to Modern Retrogramming with Plasma. This is Episode 1, Introduction to the Plasma Environment. Plasma actually consists of three components. One is the runtime command line interface. The other is the virtual machine that executes the bytecodes. And then there is a Plasma compiler and associated tools. This is showing off the Plasma command line used to navigate the file system. Here we're looking at some of the included files with the Plasma release. But it can also run system applications. So here we're going to be executing the ProDOS system utilities. This could be any system file. And we're just showing the catalog, and then we'll exit the application right back to the Plasma command line, right where we left off. Plasma has some demos to show off some of its functionality. One of our favorites is Rod's Colors. This was included with, I think, the first cassette and floppy as a demo of the low-res graphics. So I made a Plasma version of that, hopefully a little bit faster. This is a double low-res demonstration library that draws lines, tiles, sprites, both single and double buffered. That's a little sprite. You can see the hole through the middle of it. And the tiles in the background can move around. It was a fun little demonstration. Also, there's a music sequencer. In fact, the music that you heard in the background was being played with the sequencer on an Apple IIc with no additional hardware. That was just through the speaker. If you have a Mockingboard, it will play that music through the Mockingboard, sounding much better, of course. If you have an emulated Mockingboard, say with Virtual 2 or Applewin, it may sound a little different. The Virtual 2 has a little bit of issues with its Mockingboard emulation. Applewin has been fixed, and so it runs quite well. There's also a little web server showing off the TCP/IP libraries. It does require an Ethernet 2 card to be functional, however. Here is a game I wrote a while ago with help from Seth on the artwork. It's a rogue-style game, which means it's a text-based dungeon crawler. It was an attempt to ensure that Plasma was fully capable of some algorithmic, sort of real-time programs. This is using visibility as a strategic component of the game. As we walk around the cavern, it fills in what we have already seen. Plus, we have a lamp that we can extend and brighten to increase our visibility. But the lamp requires oil, so the brighter it is, the faster you use your oil. We can turn the lamp off, and if we have torches with those asterisks, those are torches that are in the dungeon. If we can see those from our current position, then they will help light up our way. However, if we're in complete darkness, then everything goes away. We can't even see our map. So we turn our lamp back on, and we can see our map, we can navigate, we see which direction we're moving. Those little ampersands are food, and then that T was a thief that was in the dungeon, and we fight them. The ones early on are pretty easy to defeat, but you want to make sure you find those ampersands, which are your food, to replenish. If your lamp oil runs low, you can go to the torch on a wall with the asterisks, take it, and that will replenish your lamp oil. That plus sign is a door. We can go through that by hitting return. And then we can navigate over here. Oh, what's that? You maybe saw a comma there. That turns out to be a key. which we will need later on in the game. I tried to make it challenging without being impossible. It may take a few tries to get out of this level. It's actually pretty difficult. Here's another thief. We'll take care of him pretty quickly. You'll notice that after a fight, you're in a different sort of random orientation, and that's to replicate a battle that leaves you kind of discombobulated, if you will. Now here we were looking through a window. Those little colons are like bars, which you can see through, you just can't get through. And we can see through on the other side is another thief. So we can see him, we can't fight him, but there's a door right here, this plus sign. So if we open that door, now we can go through, and we have more mana to eat. Oh, and there's that thief. He caught up to us, so we're going to dispatch him quickly here. We'll navigate around this little chamber. And again, you can see the visibility is something I call beam casting. I don't know if it's a common technique or not, something I kind of came up with. And it just casts a visibility beam in the different octants, depending on where you're looking and how bright your light is. And you can fill in the map as you move around. But here, up, there's some water. Those brackets are water, and I just ran into the water. I didn't have a raft, so I died. You can get some directions and more instructions on the Plasma website to show you how to play more of that game. It's kind of neat, and you can edit the map yourself. So here's the build system. It includes a bunch of the sample code, and we will run the editor to look at our very simple Hello World application. Very simple editor. We're going to skip the changes we made, go back. And now we're going to run the Plasma compiler or assembler, Plasm, on our hello.plasma source code. And the compiler launches, gives you little dots as it proceeds along to compile the source into a Plasma module, which we can then directly execute. This is the same compiler that is available as a cross compiler under, say, Unix or Windows, but it's all written in Plasma. So here we're going to bring up the editor to run ROD. And again, the editor runs, and Plasma modules are executed with a plus sign in front of them. System applications use the minus in front of them to let Plasma know how to execute them. So this is a very simple little program. It shows off, though, the use of a library, the console I/O library, which is what displays the low-res graphics so that you can reuse those libraries in each of your programs if you choose to. You don't have to rewrite everything. The compiler is written in Plasma, so it does take a little bit of time on an unaccelerated Apple II to do the compilation process. An accelerator or hard disk are very beneficial in this case. It will tell us how many bytes it has compiled, and then we can run it directly with the plus sign. And there we have our RODS colors sample program now running, just like we did in the demos directory. Now the compiler is an optimizing compiler. This is sort of a new technology I put in there about 6 months ago, and it's very beneficial. And we're showing using the Sieve of Veritasenes benchmark just exactly what it will do. So the sample code for Sieve prints out all of the prime numbers it finds. Now this doesn't make it a very useful benchmark because most of the time is spent printing out numbers and scrolling the screen. But as we get through this, we'll go back and we'll remove these print lines so that we're going to be benchmarking just the actual algorithm, and then we will rerun it. It takes a little bit of time in this case, but it is showing you all the primes. You can run the compiler on any Apple II with 64K and 2 floppy disks, all the way up to an Apple II GS with accelerators and compact flash hard disks. Really improves the performance quite a bit, makes it very snappy. There's also a 65816 version of the Plasma VM, which will give you about an additional 10% of performance. Here is the Civ benchmark, and we're going to go get rid of these 2 print statements so that we can recompile and then benchmark not just the time it takes to run it, but with the optimized version of the program. You can compare not only the size of the binary, but the execution time. So here we have 186 compiled bytes, and when we run it, you can't hear it on this screencast, but it will beep at the beginning of the benchmark and beep at the end. So if you were to time it with a stopwatch, you can compare the 2 versions. So the optimizing compiler has 2 levels. So this will be the maximum optimization that we use to compile this Civ benchmark. It takes just a little bit longer. So I actually kind of cranked up the emulator speed on this just to get through it. Notice it's only 152 bytes versus 186 bytes. And when we go to execute it, although it'll be hard to notice here, it is quite a bit faster with the optimized version. So there's the introduction to the Plasma environment. I hope it gives you a reason to try out Plasma. Hope you enjoyed it. Thank you very much.